Welcome. Welcome, everyone. We are here again on another wonderful Wednesday to celebrate God's good creation and all the efforts that are possible from the heart of faith and the people of faith. And we're going to dive kind of deep today into some pretty interesting information that gives us both sort of a sense of what is climate change and what are some pathways towards solving it? I'm going to let Kathy talk more about that, but I want to just welcome you here. And my name is Rashinda. I live in Southern Oregon, and the hills are turning green underneath. Not a lot of gold yet, but that'll come in. And then we got a little bit of snow kissing the top of the hills over here. So I don't know what it looks like out your window at your place, but introduce yourself. Let us know where you are on the planet. You can share also if you are an Earth Keeper, Earth Keeper. It's always fun to see where the Earth Keepers are. You can share how you are connected with creation justice. Have you had a win lately? And we all need to celebrate the wins even now, right? As we all watch sort of the movement in our wider political lives for what is and isn't funded at the moment, we can also celebrate the fact that we are here and people of faith are showing up, and very much appreciate that. So your hosts today are myself and Dawn and Kathy. And so if you need anything, you just let us know. And Wendy, Austin, yeah. Center of the country has had just a heck of a lot of storm weather. So really in prayer as people come through that. Um, so I want to just at this point say that we're here on Wednesday, the third Wednesday of every month, but we are going to have a special follow-up cafe to this one in about 6 weeks and dig even deeper into the solutions question that has solutions that have to do with regions. We invite you to bring your green team and load up on some ideas for what kinds of things you could bring to your green team and your conference that might be solutions that really work in your region. And so giving you information and opportunities to explore that is really our goal there. So I'm going to turn it over to Kathy Velasquez Eberhardt, who will talk more about this wonderful thing called the United Methodist Creation Justice Movement. Give us a bit of a nutshell in what we're doing today.
Thanks, Rashinda. So good to see so many of you here, both those of you that I know and those of you that I don't. It's always a thrill to see new faces and new folks joining us in this space. Greetings from very blustery Minnesota. The wind is really quick, and every so often I get a warning that my internet's unstable, so I hope I stay around, but if I don't, that's probably why. I am a United Methodist layperson and a commissioned Earth Keeper, and one of many leaders who have helped to launch the Creation Justice movement in the last number of years. The United Methodist Church does have a lot of statements and a long history, actually, of affirming a vocation of creation justice. But as those of us who are in this movement have come to really understand the urgency of climate change, the urgency of the problems with our planet at this moment, we've realized that we want to do more. And so while there are ways that we're acting in the world and in our communities, as United Methodists, we've wanted to also take additional work effort in our own denomination to bring this institution to bear, to bring our faith to bear on this important work. Now, the Creation Justice Movement, you can learn a lot more about that on the website. If you're new to that, we have a number of work teams that include worship and solar advocacy, communications, annual conference organizing, and more. And we also have this monthly space, as Shinda said. So I'm so glad you're here. Now, in kind of introduction to what we're going to be doing today, I'm two things come to mind. One is that kind of a understanding of trusting the Spirit. We at first were thinking about doing this last fall, but it ended up happening today. And I feel like it's really appropriate in this context, this moment in time, a time when we've just seen, again, additional unrelenting storms, fires, floods, drought, all kinds of ways in which our climate is really acting up. It's also a time when the United States is stepping back as a country, at the federal level. I'm going to drop in the chat. United Methodist Insight, Insight has a really good article that compares our social principles to what's happening right now. And so as that rollback is happening, the United Methodist Church has an opportunity to actually step forward, because at our last general conference, we passed several commitments to addressing climate change, to committed to being in net zero greenhouse gas emissions, that kind of thing. So this context for today, the conversation we'll be having, both allows us to step in with some boldness to keep talking about climate change. And to understand that we have an important role to play as a church. So that's a piece of it. Now that I'm going to introduce Bill here next, because Bill is somebody I've actually known for over 10 years. We participated in some Minnesota Interfaith Power and Light activities together, and then we're part of a small group that carpooled from Minnesota to Georgia for the very first EarthKeepers training, and that was a delight. We also got to carpool again to the 2018 Creation Care Summit in Nashville. He's a great person if you need a carpool, I tell you that, long road trip. But I lift up Bill because he is an example for me of ways that a lay person can really take this call and live it out, the call that we all as United Methodists have to transform the world, to do good work in the world. And so he's done that in his congregation. He's increasingly been out in the world doing speeches about climate, and now most recently has gotten on the board has been elected to the board of his local electric co-op, Great River Energy and Dakota Electric Association board. So brings a lot of experience to our conversation today. And I'm just super excited that you're all getting to hear it. So I'm going to turn it back to you, Rashinda, and then we'll move into the presentation.
I think we're ready to go. I think we're ready to just jump right in. Bill, we are just really glad you're here and looking forward to, I have some uh, previous, sort of layman's knowledge of climate science and gets me by. And I also imagine that I'm pretty Swiss cheese, right? I got these big holes. I didn't take environmental science in college. So glad you're here to just give us that sort of refresher for those of us that it's new, kind of opening our minds to that, and those of us who know most of this or some of this, that there's an opportunity to go, aha, oh yes. So I'll turn it over to you.
Thank you all. I'm so appreciative of this opportunity to meet with you. I see some friends in the audience. Nice to see you again. I am aware that you are all very committed to this movement to address climate change, that you already know quite a lot and don't need to be convinced that climate change is real and it's a threat to humanity. So my goal today is to arm you with some knowledge and some tools that you might be able to use as you go out into the world and try to move the needle on how society is treating our world, how we get our energy, how we use our energy, and how we can address this problem of climate change. I want to explain a couple of things here. First of all, I have multiple screens here and I have to look up to see all of you, but I'll try to keep my eyes on the camera. And I guess that's it. I'm ready to get into this talk. This is the structure of the talk. First of all, oh, and I wanted to correct something. Sorry. In the bio about me, it said that I had training in climate and meteorology. I actually had a degree. My first degree was undergraduate in meteorology with a lot of training in climatology. I continued on. I only worked for me as a meteorologist for 2 months. I continued on with a graduate degree in computer science, and that was my career. But I always loved the science of climate and meteorology, and I took the opportunity to use that knowledge, that experience, that training, dust it off around 2005 and start becoming an activist. I learned about climate change when I was a student in the 70s, but at that time it was still a debate among scientists about what impact it would have. The science of climate was known for more than 100 years at that point, and how climate change would be affected by carbon dioxide. But the scientists were still debating about what it meant for humanity. So I didn't pursue that. I watched from the background. as the interest and concern grew until about 1980, when James Hansen spoke to the legislators and convinced them that we needed to do something. And it actually started to take off. We saw that the first President Bush, George H.W. Bush, was actually campaigning on the need to do something about climate, but did not have a receptive legislature. We actually saw in the early 2000s when a bipartisan movement to do something about climate happened, and we actually had Nancy Pelosi and Newt Gingrich do a commercial together where they said to America, you know, we don't agree on much, but we agree on this, that this climate change is real and we need to do something about it. But in the late 2000s, around 2008, 2009, at the time that An Inconvenient Truth came out, the fossil fuel interest kicked into high gear with a PR disinformation campaign and really put us behind the eight ball in terms of doing something about climate. And that's when I decided that I could not sit back. I had to take my knowledge and training and dust it off and do a lot of research, because when I was a student, there wasn't a lot of talk about climate change. But I did a lot of research and caught up on the science, and now I'm going to try and present some of that to you today. And I became involved, as all of you are doing. So first of all, the most important thing is to understand that the worldwide environmental energy balance is changing. And I talk about this as an energy balance, and you'll see in a minute why I'm calling it a balance. And what does this mean for humanity? What can we do about it? And what is the next step that you all can take? To begin with, I like a little bit of humor. This is a Gary Larson cartoon where grandma's on the floor. The kitchen is, suffered a huge explosion. Everything's in disarray. And on the floor is a cookbook that grandma's been using called Recipes for Disaster. What we are doing, the chemical experiment we're doing in our climate, in our atmosphere, is a recipe for disaster. The way we live our lives, the way we get our resources, and the things that we enjoy so much that we get from abundant energy are a recipe for disaster. So first of all, it's important to understand that almost all the energy on Earth comes from the sun. And it comes in constantly streaming in at a huge amount. It is far more than all the sources of energy that humans create by digging up fossil fuels, by using uranium, by tapping into geothermal energy and so on, is a very small fraction of the amount of energy that comes in from the sun. As that energy streams in from the sun, it comes in as short wavelength visible light primarily, and that goes through the atmosphere transparently. The atmosphere is like clear glass to the incoming sun, except for some reflection off of clouds and some scattering that occurs. The energy tends to flow in. It hits the Earth's surface and warms the surface, and that warms the air, and that air warms the oceans, and so on, and provides the environment that we enjoy. If all that energy stayed on the Earth and never left, in time, and not very much time, the Earth would be as hot as the sun. Think about that. It would be as hot as the sun. So all that energy that's streaming in has to stream out again. Now, after it heats the Earth, the energy radiated from the Earth is a function of the temperature. Just as the energy from the sun is a function of its temperature and comes in as visible light, the energy from the Earth leaves as infrared light, a much longer wavelength, and a much different interaction with the chemistry of the atmosphere. Now, suddenly, the major components of the atmosphere, oxygen and nitrogen, still are transparent, but the greenhouse gases like carbon dioxide, methane, fluorinated gases, I'll call them F gases from now on, and other elements of the chemistry of the atmosphere, they absorb that heat. They are opaque to that energy. As it's trying to stream out at the speed of light, as radiation always does, it only goes a short distance, about one meter, and it runs into a molecule of greenhouse gas. It causes that molecule to warm up, and then that molecule radiates its energy back out, because now it's got more temperature, it's going to radiate that energy. That energy gets radiated in all directions, not just straight out to space. So some of it gets radiated back down to Earth, some of it gets radiated to the sides. And then a metal ball in a pachinko machine, if you know what those are, a pinball machine, it's just bouncing around in a process called re-radiation. So you have a bit of radiation, it warms up a molecule, that radiates again, it warms up a molecule, it radiates again, until it reaches a point high enough in the atmosphere where the greenhouse gases become thin enough that it can finally escape at the speed of light out to space. The longer it takes, the more re-radiation that occurs, the higher the temperature on the Earth. If there were no greenhouse gases on the Earth, the temperature of the Earth would be like a rock in space, like the moon. The average temperature would be about 0 degrees Fahrenheit. That's physics, straightforward calculation. With the introduction of greenhouse gases, the amount of energy that is retained warms the surface of the Earth up to an average of about 57 degrees Fahrenheit. Substantially warmer, and it makes it possible for liquid water to exist on Earth and for all of us to make this our home. Now, you change the chemistry, you change the thickness of that opaque layer, and you slow down the flow of energy out of the Earth, through the atmosphere out of the Earth. I have a picture here that's kind of like a beaver making a dam in a stream. And that's kind of the way, that's an analogy I want to use for the energy that flows from the sun to the Earth and back out to space. The atmosphere, the greenhouse gases that are beneficial, that raise that temperature to 57 degrees, they slow down the flow like a dam in a stream and cause a reservoir to build up behind the dam. That reservoir of energy behind the greenhouse gas dam should be 57 degrees, but we keep adding sticks to the dam. Like a beaver, we're busy adding sticks all the time. We're adding carbon dioxide, we're adding methane, we're adding F gases, and we are slowing the flow of energy out. The more we slow that, the more that dam, that reservoir, we're making the dam higher, that reservoir gets higher. Now, as you can imagine with water, if you have a permeable ground around you, or if you have an island in the stream, that island starts to become inundated with that higher reservoir, or the water flows through the ground and comes out in other places that are low. And in the same way with greenhouse gases, we have energy flowing out of the air and into the ocean. We have energy flowing in a lot of different ways, trying to reach a new equilibrium relative to the amount of greenhouse gases that we're having in our atmosphere. Now, we don't stop at a certain level. We just keep adding, and that's really the crux of the problem, is we just keep adding. So we're chasing a moving target as we try to address climate change with mitigation and adaptation and resilience. I wanted to just throw this bit in here just to demonstrate how long we've known about climate change. In 1856, Eunice Foote, a brilliant woman, had done a little experiment where she had a jar full of greenhouse gas, carbon dioxide, and a jar of normal gases. And, at this point, science was really beginning to understand and learn about the different gases that comprise the atmosphere and the effects of radiation on those gases. And she measured that when you have sunlight passing through a jar of ordinary air and a jar of carbon dioxide, that the one with the carbon dioxide warmed up. So we've known about this for a long time, and in the late 50s, we started to measure the amount of carbon dioxide in the atmosphere to see how much risk we had in terms of putting the energy out of balance. There is a chart here, I thought. There we go. The Keeling curve. This scientist named Keeling started to measure carbon dioxide in the atmosphere in an island in Hawaii, where the air was so clean, really isolated from industrial sources. And the idea was that that would be a good place to measure carbon dioxide. So he started measuring it every year, and you'll see that there's a sawtooth pattern here. So that sawtooth pattern is because the seasonal variation in carbon dioxide is relative to the amount of organic growth, trees, plants that In the summer in the northern hemisphere or the summer in the southern hemisphere, these plants spring to life. They take in sunlight, they produce chlorophyll, and through photosynthesis, they absorb carbon dioxide and they build it into the plant material. Then in the winter, those plants die off and they release that carbon dioxide to some degree. Now, the northern hemisphere has more land mass than the southern hemisphere. So in the northern hemisphere summer, we take up more carbon dioxide than we do in the southern hemisphere summer. And that's the reason for the sawtooth. So the peaks are the winter in the northern hemisphere, and the troughs of each of these sawtooth patterns is the trough is the northern hemisphere summer. Now I drew a red line in here. That's not part of the normal graph for the Keeling curve to show that's a straight line, to show what a straight line growth in carbon dioxide would be like. And in fact, you can see that it's not linear, it's exponential. And so with each passing year, the carbon dioxide problem gets worse and worse. Now, something I want to point out about this, and it's a bit of disinformation that you'll hear about greenhouse gases, carbon dioxide in particular, is people will say that, oh, the volcanoes put out far more carbon dioxide than humans do. That's false. The truth is it's about 1% of what humans produce. But what I want to show in this chart is you might remember a very massive volcanic eruption in Pinatubo in the Philippines. Now, I don't remember what year it was, but if what they were saying was true, then you ought to be able to see it here. You ought to be able to see it as a big spike in the amount of carbon dioxide in the atmosphere, and you don't. I don't see it. I don't see it at all. All right, going back here to where I was. So the amount of greenhouse gas has, the carbon dioxide has grown since the beginning of the industrial age, about the 1850s or so. And as I showed you, it's been increasing exponentially. And the question is, what does this really mean? Well, that 57 degrees of climate stability of average temperature around the Earth, we reached that point about 10,000 years ago. This chart shows the temperature from the end of the last ice age as we warmed, and we came up to this dotted line, which is the zero mark is the I believe it's the average of the window from pre-industrial times. But you see it came up and it stabilized, and then there was a little bit of adjustment again in about 8,000 years ago. Now, what does that mean? And then it's been declining. We're actually sliding toward the next ice age, or should be if we didn't have climate change. But if you think about recorded history, it goes back about 8,000 years. So over the last 8,000 years, even though humans have existed for far longer than that, it was really about 8,000 years ago that we started to become organized into communities, cities, and we began to build the wealth of society on the margins where we could make a living, where we could grow crops, where we had reliable access to water, and all of those natural features define our boundaries. We don't build anything out west to speak of in the desert because we don't have access to water. And that's the way it's been for 8,000 years. And, we build in along the coast of the Atlantic Ocean, along the coast of the Pacific, in various parts around the world. We built based on that really stable environment for the last 8,000 years. So that's changing. And so it threatens the wealth of humanity. Now, this chart is just 2,000 years long, and I include this one to show again the remarkable stability of the environment for 2,000 years until recently, when we have dramatically changed the amount of greenhouse gases, and we have this hockey puck effect, hockey stick effect. And you can see that we're going into unknown territory. what we know about weather and the ability to predict weather, to the ability to have reliable agriculture, it's all based on the past that has been very stable, and the future now is not stable. The future is a huge unknown. This chart is a way of demonstrating the climate anomalies, the temperatures, based on the period from the average from 1950 to 1980. And as this is an animation, and what you're going to see is like a clock going around the months. Every time you go around, it's 1 year. And you're going to see white, meaning stable or average temperature near this green line, which is 0 degree change, 0 Celsius change. And then if it's colder than that, it'll be blue. And if it's warmer than that, it'll be red. So let's take a look at that. And what you see starting in 1880 is that there's variations every year, small variations. But for the most part, we see a lot of white, a pretty stable temperature. You'll see when we get into the 30s, there'll be a warm period that correlates with the Dust Bowl era. But it comes back. It's not real red. It's sort of pinkish, and then it comes back. And now we get into the modern era. And when we get to 1980, you're going to see a dramatic effect. It's suddenly going to get a lot more red. And 1980 was a critical year. As I mentioned earlier, that's when James Hansen appeared before Congress and told them that this is a serious problem and we need to do something about it. Since 1980, the effects of climate change have become larger than the background variability. And so now the question is there any question about what's happening? And as this chart turns to the side, you can see that we had basically a column, a consistent temperature before 1980, but since 1980, it's going out like a water tower. And there's no question where it's going. There's no question about whether this is a temporary effect or a trend that is really threatening. This is another way of looking at temperature anomalies. Many of you, I'm sure, understand what bell curves mean. The key thing about bell curves, this is a distribution of measurements of samples, and this bell curve is very natural. Most of the samples are right in the middle, or that's where you have the peak. Above that average is standard deviations of 1, 2, and 3 and more. And mathematically, the bell curve follows a very clear pattern, and that is that within a standard deviation above and below, you have 65% of the samples. Within 2 standard deviations, you have, I believe it's 98% of the values. And within 3 standard deviations, you have 99.7% of the samples. So we have extremes of cold and heat, and they would be out beyond the 3rd standard deviation, but there aren't very many of them. It's 0.03%, 0.3%, sorry. Now, as I start this animation, you'll see 1950 these are 10-year averages, and you're going to see the movement of this curve toward the hot side. And what's particularly dramatic about this is that now if you look at the 3 standard deviations where 0.3% of the samples were, now that 0.3 is beyond the 3 standard deviations. That 0.3% has become huge. So we're going to have a lot more anomalies on the hot side, much rarer to have anomalies on the cold side. They're still there, and people will hold them up and say, see, it didn't change because we still have this outlier, but that's very rare to and you can't draw a conclusion from that. All right, so we have this unbalance of energy flow. We have more energy flowing in than we have flowing out until we reach a new equilibrium. We don't know what the weather, what the climate will be like at that new equilibrium because we haven't experienced that in our past. And we keep changing that. So the equilibrium keeps chasing after that changing number. So what does it mean for humanity? And this is where I'm going to spend the least amount of time. But again, to begin with a cartoon, this is a Gary Larson. Again, he's my favorite. He said, "This is it, Jenkins, indisputable proof that the Ice Age caught these people completely off guard." And there's Ugg in the outhouse looking out, wondering what's happening, and it caught him by surprise. We aren't surprised, but we are going to be surprised by new phenomenon and new ways of existing in this world. So first thing I want to mention is Corey Stringer, a Vikings football player who died as a result of practicing in high humidity. Humidity is one of the effects of climate change. The human body cools itself by sweating, and as humidity rises, the ability to cool our bodies becomes more difficult. With the dry environment, humans can survive up to about 124 degrees Fahrenheit for 6 hours. And that's kind of the threshold, 6 hours. With high humidity, the dew point, which is a measure of the humidity, actually a dew point that gets close to the body temperature of 98.6 degrees makes it impossible for us to cool our bodies. We cook our brains. You know, if you can't get out of the heat and humidity into some air conditioning environment, then you're going to die within 6 hours if the humidity rises close enough to the body temperature. And it's actually somewhere around 94 degrees dew point. We've actually had some dew points in the world above that in the Arabian Peninsula area. So it's coming, and that didn't used to happen. Of all the different kinds of effects that happen with climate change, the scientists will give a probability of how likely it was or what percentage factor climate change played in a particular phenomena. When it comes to wildfires, it's a very, very strong correlation. And that is because we get these atmospheric rivers that encourage a lot of growth. That plant material stores that carbon, which is a fuel for fires. Then we follow those atmospheric rivers with drought, and then all it takes is a spark, and you have all of that fuel. You know, you might think that it's the forests that are the biggest problem, and they certainly are a problem, but it's the low growth that grows quickly and dies and provides fuel that is actually a bigger threat. So it's leading to longer fire seasons, more intense, higher amounts of damage from fire, and very strongly correlated. I told you about how if the temperature, the dew point is above about 94 degrees Fahrenheit, you can't live there. And so it's important to look at what's happening around the world with temperatures and recognize that if you are a society that doesn't have access to air conditioning and ways to escape the heat or ways to mitigate the effects of drought and variability and rainfall and all of that, if you don't have the ability to deal with that, you're not going to stay in your home community, going to migrate. And migrations, you know, even if there's only one day a year that you can't live there, you're going to have massive amounts of people moving. And we have places like that in the world today that are uninhabitable, in effect, uninhabitable because of climate change. And so that movement causes destabilization of governments as people react to what they feel like is too high an amount of migration. So this is just to highlight a couple of exceedingly hot temperatures that have occurred. And we've experienced some of them. A couple years ago, there was this massive heat dome over the Northwest United States and Canada in that area. Portland broke its all-time record. Many areas in that area of Canada broke all-time records. We also saw very high temperatures in Seattle, Washington. And again, you know, understanding that we've built to a particular climate that we've been used to. You go to a place like Seattle or Portland, a lot of people don't have air conditioning. They haven't needed it. Well, now they do. And so society, you know, here we can change. We can go out and buy air conditioners, but, you know, in some places of the world, they can't do that. But we're seeing much more intense and much more destructive hurricanes. You all know about that. And in particular, I want to mention for our members who are from North Carolina, we experienced some tremendous damage from Hurricane Helene this last year, where the extent of damage from the hurricane was exacerbated by the fact that there was so much rainfall. The rainfall fell before Hurricane Helene, saturated the ground, and then when the storms from Helene came, that moisture in the ground continued to provide fuel for the hurricane. So the hurricane's effects went farther inland, and places that had been somewhat immune from the damage of hurricanes now suddenly found themselves experiencing tremendous damage, and North Carolina suffered greatly from that. This is hail. And I include this one because, you know, a few years ago, we had a lot of flooding in the Middle South. And the fire truck is floating. If we, who's going to save us if the fire truck is floating? And of course, as people of faith, we are very sensitive and aware of our responsibility to people who around the world who are affected by our actions. All right. This animation, and I'm going to play it twice here, this shows the desertification of America from climate change. I'm going to back up here, and I want you to focus on the upper Midwest, Minnesota, where I live, going from being a very moderate climate with a reasonable amount of moisture throughout the year for growing crops, suddenly becomes more drought impacted than any place at the beginning. This is the beginning. There are none of those dark brown areas. And at the end, Minnesota is one of the most drought impacted areas of the country. All right, so what can we do about it? Well, first of all, we have to recognize where the greenhouse gases are coming from. And there are many sources. It's throughout the way we live. I want to point out at this time here, I know a lot of people are focused on setting an example by being carbon neutral in their life, right? Net zero carbon in your home, in your car, in your travel, and so on. That's great. I love it. But consider this. That's only 40% of the attributable carbon dioxide and greenhouse gases per capita. So when you've eliminated carbon from your own life, there's still 60% of your carbon impact is in this system that provides all the resources we have in America. So we need to really step up the game and figure out how to provide solutions that are inviting, that are comprehensive, that people want to adopt, because we need to change society and we need to change it all over, all right? Currently, and this I think is maybe 2020, this a few years out of date, we have these major segments of greenhouse gas emissions. We should focus on the biggest ones first, or put the most effort and the most money into the biggest ones. Although we do, I think, need time to implement solutions across the board. So we don't want to lose sight of any of these areas. But I want to point out here that we are seeing progress. This chart used to say that electric power was the biggest source of greenhouse gases in America. Now it's less than transportation. So the effect of solar and wind and it's switching over from coal to natural gas, which produces about half as much greenhouse gas per unit of energy, has had an effect, and it continues to have an effect. And so it's both good and an indication of how long it takes to create these solutions. So keep that in mind. All right, now I think this is the part of the presentation that I find most interesting. I hope you do. These are tools that you can use as you go out and do your work and you try to lead our communities in making change. This En-ROADS model is what's called a system dynamics model or simulation. The reason for dynamics is that everything's interrelated. It's like everybody getting on a trampoline. You move, I feel it, right? And that's the way our systems are. So if we as individuals using our own brains try to calculate, all right, what's the impact of driving an electric car? What's the impact of planting more trees or changing agricultural practices? It's hard for our brains to comprehend all of those interactions. That's where the En-ROADS model helps. It has all of those interactions built into the model, and every time you change anything about the model, the application automatically does tens of thousands of calculations and presents you with this integrated result that takes into account all the dynamics. It is a global model. It had to be in order to be workable. It's implemented in a web browser, in a web page, so that anyone can use it. It's free to use. And I'm going to try and teach you how to use it here in a moment. But it doesn't run on, it only runs on computers. It does not run on phones and iPads and that sort of thing, because they don't have enough horsepower to do all these calculations. But if you're, on any other kind of web browser on a computer, you can use this. The key thing about this is it doesn't predict what's actually going to happen. It depends on what what actually happens is depends on what humans do. And the model can't know that. But what you're trying to do as you use it is to say, this is what humans could do. What would be the effect of that? All right. And the goal of this model is really to adjust our assumptions, our misperceptions, and to increase insight into what solutions are most valuable and have the best impact. And it's constantly being updated. So I'm very encouraged by that. Every time I've done a deep dive in any of the answers that I get out of En-ROADS, I find that the science is solid. And so I use it like a pocket calculator for climate solutions. And if somebody asks me a question, I can jump on and do a little bit of a reality check in what my thinking is and see, is this really going to work out in the future? All right, so the En-ROADS website is, and you can write this down, yes, climateinteractive.org. climateinteractive.org, and then you'll see on there a button for En-ROADS, and then it'll give you some explanation of what En-ROADS is, and then there's another button you can click. Thank you for putting that in the chat, Kathy. You can click on the En-ROADS button, and it'll take you into this, right? And what you have here is a whole bunch of knobs for things you can change, and then graphs that show you the effects of those changes. On the left, you have where we get our energy from. On the middle, you have where we use our energy, including in population, because there's a per capita amount of energy, and more population means more energy used. I want to just put a caveat on that right now. Many people will say, well, to solve climate change, we have to reduce the population. So that's not Christian. They might have arguments for that, or they might be really snarky and say, why don't you kill yourself? You'll do a good thing for the environment. The reality is, if you decarbonize society, then the population doesn't matter. If you decarbonize society and the economy, then economic growth doesn't matter. Normally, more population, more economic growth would have more of an effect on the climate. Now, there's other reasons in terms of the resource and the carrying capacity of the globe about worrying about population and economics. But from the perspective of climate change, it is orthogonal, to use a math term. All right. And then on the right, we have ways of mitigating climate change by getting rid of or reducing the sources of greenhouse gases. So I'm going to take you through, and then the slides up above. These charts, there are many, many charts you can choose from. And you do that by just clicking on these gray bars above the charts. These are the default charts, one showing where we get all our energy from. And that is all energy, not just electricity. The bottom one is coal, that's brown. The red one is oil. The blue is natural gas or methane. The green is renewable energy, wind and solar and other sources. The pinkish one is bioenergy. That's wood and other sources of, ethanol and biodiesel, things like that. And then a very thin line above that is nuclear energy. On the right, you see the total greenhouse gas emissions per year. And as you can see, again, from that chart I showed you from the Keeling curve and showed how the amount of greenhouse gases is growing exponentially, this chart shows why. Every year we keep adding, you know. We need this chart on the right to go below zero. We need it to at least get to zero so that we stop increasing the greenhouse gases and we stop moving that equilibrium point. But if we're going to bring the Earth back to something that is more manageable and what we're more used to, then we really should bring this curve below zero. And then on the far right, you see a guesstimate, an estimate of what the temperature will be in the year 2100. This model runs for 100 years. It's already got 25 years of history because it starts in the year 2000. And you can see that the model and reality correlate well, which means that this is a good model for the future. It has a reasonable chance of predicting accurate outcomes. And remember again that this is a global model. This assumes that everybody on the planet follows the decisions that you make as you plug into this program. All right, so I want to try out some things, first of all, that you might have heard are ways to address climate change. First of all, what if we have a moonshot program and build a ton of nuclear power? Now, I want to point out on the left that I incentivize nuclear, subsidizing it, trying to accelerate the development of nuclear power. And because this is a dynamic system and everything's interrelated, I also need to disincentivize the fossil fuel sources and also to incentivize reducing carbon. All of these things play into the economics so that the decision makers at power companies and so on are finding that the best solution, the most inviting solution, the most economically advantageous solution is the one we want. In this case, we want to go to a lot of nuclear. Just as an example, I'm not making a point here about nuclear, but just as an example, if we think nuclear is the way to address this problem, this is how we do it, all right? I want to also point out something interesting, and what I found in playing with this model is that bioenergy actually increases greenhouse gases. So you'll see here that I heavily tax it to disincentivize it. All right. The black line is status quo. On the right, the greenhouse gas net emissions. The black line is status quo. The blue line is the results of the changes that we've selected. And as you can see, we don't start, well, actually, we start seeing a decline immediately, but we don't reach the maximum effect until about 15 years from now. And then we continue to have a slight decline. But again, this is the greenhouse gas emissions. They're still positive. They're not as low as we need them to go. So putting all our effort into nuclear isn't the answer. Let's see here. It was 3.3 degrees Celsius or 6 degrees Fahrenheit expected temperature at the end of the century. We reduced that by 0.6 of a degree or 1.6 degrees Fahrenheit if we have this nuclear moonshot. Over on the left here, you'll see that we have increased the amount of renewable energy as a result of the solutions we've chosen. We've also increased the amount of nuclear energy, but what's interesting about this is that we don't see much of an effect for 15 years, and then we start to see a strong increase until about 2060, and then it plateaus. And there's a lot of reasons behind that. I can only speculate, but I assume that the cost of nuclear energy continues to be much higher than renewable, and so the economics for going with nuclear will play out and stop being advantageous. So this is a good step, but not a solution. How about a renewable energy moonshot? So we do the same thing, but now we don't incentivize nuclear, and we see where that gets us. As you can see, it's the same effect. So we don't need the nuclear. We have the technology we need with renewable energies. We don't need the nuclear. So we can avoid the cost, because it's a big cost. We can avoid the political blowback from trying to go nuclear. And although there is a slight growth in the amount of nuclear, that has to do with how the electric industry manages the flow of electricity, meets the peak demand, and so on. The reality is we don't need much more nuclear. Nuclear, by the way, in case I'm assuming you all know, is considered to be a zero carbon resource. Reality is there's some carbon in it, especially because of the concrete that's involved in building nuclear power plants, but it's generally regarded as a zero carbon. All right, how about hybrid vehicles? What if everybody and every truck, every plane, everywhere we could, we used hybrid technologies to maximize efficiency of transportation? As you can see, it's not a very big effect.
Wow.
3/10 of a degree Fahrenheit. The effect doesn't happen until about the mid 40s. And then it really just plateaus. It doesn't bring things down. We continue to use oil and other fuels for transportation, and we'd really like to try and get away from that. The next one is, okay, what if we go with 100% EVs, but we don't change anything about the electric power industry? And what you'll see is there's only a very slight difference in the amount of greenhouse gases we produce and the effect on the temperature, 1/10 of a degree Fahrenheit. So EVs by themselves are not an answer. Remember, everything's integrated. It's a dynamic system. All right, if we go with low carbon power, now you see a much more dramatic effect. The amount of energy that comes from oil has dropped to a very small amount. And we have a much bigger impact on the climate. We lower the temperature by 1.8 degrees Fahrenheit. And that's a good thing to do. All right, high efficiency buildings. Buildings in industry are low hanging fruit. We use a lot of energy, and there's a lot of opportunity to upgrade buildings so they're more energy efficient. And certainly in building new buildings, there's a lot to be optimized. Interesting thing about buildings that I'm just going to throw in here is that the lowest greenhouse impact building is the one that's built. In other words, if you've got a building and you spend a lot of money and a lot of energy and a lot of resources to make it more energy efficient, the net effect tends to, the resources that are used to make that building efficient tend to offset the greenhouse gas reductions. So we certainly want to build new buildings with high standards for efficiency. Now, if we don't just simply make buildings more efficient and industry more efficient, but we also replace traditional sources of energy, oil, coal, with clean electricity, then we see a much more dramatic effect. Now, almost 2 degrees Fahrenheit reduction, a dramatic reduction in the annual production of greenhouse gases, more than cutting it in half. So good thing to do. And here in Minnesota, we have what's called the ECO Act, which incentivizes that kind of activity. So I'm encouraged by that. Now, I've talked about carbon dioxide, but other greenhouse gases are methane and the F gases, the industrial gases that are produced for things like solvents and refrigeration. They're used in industrial processes. And if we look at their net effect in greenhouse gas equivalent, carbon dioxide equivalent, you'll find that methane is about 20 to 25 times more impactful than carbon dioxide. And these F gases, these can be extremely impactful greenhouse gases, with some of them being 25,000 times on a per unit amount compared to carbon dioxide. So we want to be very careful in controlling methane. Don't let it leak out. It's much less harmful if we burn it than if we just let it leak into the atmosphere. And these F gases, to make sure that the cradle to grave treatment of these gases is carefully managed so that we're not releasing them into the atmosphere. Right, carbon capture and sequestration. You'll hear people talk about how we can continue to use fossil fuels if we capture the carbon dioxide and pump it into the ground for permanent storage. The reality is it is not very effective. It's very expensive. The amount of energy it takes to turn a traditional coal-fired power plant into one that captures less than 100% of its carbon dioxide. It still releases carbon dioxide because you can't get to 100% cost effectively, but it consumes about half of the energy that the power plant produces. So it's, there have been experiments with it. There are major projects that are underway, and frankly, they're not being successful. So you don't hear many people talking about carbon capture and sequestration. Even the proponents of it realize that it's a money loser. So, and finally, I put all this together, and I want to show you that it is actually possible to have a solution. I turned all the knobs in all the most favorable directions, and I can get the carbon dioxide, the greenhouse gas emissions to zero by about 2065. They drop pretty dramatically right out of the chute, and then they taper off, and it's very hard to go below zero, even when you apply all the ways to actually remove carbon dioxide out of the atmosphere through machines or through enhancement of natural processes. But we have the potential for a solution. And the graph on the left here, which is the first time I'm showing this graph, is the temperature change between now and the end of the period, 2100. There's two dotted lines. There's two dotted lines. The lower dotted line is 1.5 degrees Celsius. The upper dotted line is 2 degrees Celsius. 2 degrees, as you'll remember, was the goal of the Paris Accord. But as the Paris Accord was being finalized, nations, particularly Pacific Islanders and other nations that are very close to sea level, who knew that the track we were on was going to destroy their environment. They were not going to be able to live there. And they came before the Paris COP and said, please have a target of 1.5 degrees. So the scientists started working on that, and there's a lot of advice and ideas about how to approach 1.5 degrees. But you can see that with all of the knobs turned to max, everything up to 11, we still exceed, and we currently actually, I believe we have exceeded 1.5 degrees. But we can round the curve and we can bring it back down again. All right, so what's next? First of all, we have a lot of solutions. We should embrace them. You heard it mentioned that I'm on the board of Great River Energy. That's a generation and transmission cooperative here in Minnesota. And I'm on the board of my distribution cooperative that distributes electricity to all the homes around me. And I have seen presentations that talk about how we're going to meet demand in the next few years, going out to about 2050. And as many of you may know, in Minnesota, we have a law that says we have to have carbon-free electricity by 2040. So these companies, these cooperatives are focused on that, and they're trying to figure out how to solve that problem. So I listened to a presentation where they talked about a staging of different kinds of solutions, the ones you could immediately implement, and then how they would play out over time. Then the next tier and the next tier. The highest tier, the one that takes the longest to solve, was to deploy. That was nuclear, which I find encouragement from. The bottom one, the one that's most readily accessible, and we can build it today, is renewable, wind and solar. Again, I take a lot of encouragement from that because as we develop those less dramatic solutions, we will find ways. There will be improvements. There will be innovations. There always are. Expect innovation. There will be cost reductions. And so I think as we get closer and closer to that point where people think we need to have nuclear energy, the need for it is going to sort of melt away. Okay, that's what I believe. Now, in our talking with our neighbors and our friends, our communities, we can demonstrate through our own behavior how we have adopted technologies that are not just sacrifices, but enhancements to our lives. Switching to LEDs has saved me a ton of money. Lowering the temperature in the winter, raising the temperature in the summer. Those are effective means of reducing your carbon footprint. Um, there are ways, maybe some people aren't going to like this kind of a solution, but there are ways to demonstrate how you can do this in a way that, as I said, is inviting because it saves money and enjoyable if you do it the right way. But the key in all of these things that we do, in my opinion, is we can't make them sound like sacrifices. If we talk to people in a way that says, I've done this great thing and I like it and you'll like it too, but yeah, I understand it's a sacrifice. People aren't going to adopt those. If they do, they will do it for a while and then they'll stop. Or they'll do it and then feel like because they've made a sacrifice, they've done something altruistic, they deserve a reward. And oftentimes the rewards counteract the benefits of the action that they're taking. There's been some studies on this kind of behavior. As an example, some people were asked to do something altruistic, and then the researchers presented them with a plate of cookies, said, here's a reward, take some cookies. And they had a control group that didn't do anything altruistic, and they presented them with a plate of cookies. The people who made the sacrifices, they took more cookies. There's also research that has shown that people who take reusable grocery bags to the store tend to put more goodies in the bag. We feel like when we've done something good, we deserve a reward. I have friends who have really worked hard to make their lives net neutral or carbon neutral. And they've switched to all electric vehicles. They've actually moved so that they don't have to drive as far to work. They've built a home that was architecturally designed to be net zero. It's got heat pumps, it's got solar, it's got even water management. So the water that comes off the roof is all managed. They've done all these things, right? It's amazing. Spent a lot of money and they have a beautiful home. And every year they reward themselves by taking a trip to Europe. Okay, so we can't ask people to solve this problem by making sacrifices. We have to demonstrate solutions that are exciting and inviting and improve people's lives financially or comfort-wise or opportunities to do things they like to do. That has to be in the solution. Otherwise, we can't bring along all the people we need to do that we need to bring along. All right, so the most important step of all is to talk about it. So when you are out in public, when you have an opportunity, and these opportunities come up where somebody's talking about something and you just mention, hey, by the way, did you know? uh, uh, do that, talk about it. I'll give you an example. I was at the board meeting for Great River Energy, and one of the directors was talking about how their cooperative, their distribution cooperative, had implemented a solar farm. And I said, oh, did you know? Oh, and he mentioned that it was very important that they found a place for the solar farm that did not use arable farmland, productive farmland, because that's a big deal around here. The farmers are saying you can't take food producing land out of production to do solar. That doesn't make sense. Well, if you take an acre of corn that you raise to make ethanol, you turn that ethanol into an equivalent amount of fuel and you put it in a fossil fuel car, drive that car, you can drive about less than 10,000 miles. If you take that same acre of land here in Minnesota, in the northern climate, and turn that into a solar farm of 1 acre and take that electricity and use it to drive an electric vehicle, you can drive that electric vehicle from 500,000 to 750,000 miles. And the jaws dropped. And I said, "You're skeptical?" And they said, "Yeah, we're skeptical." And then they started talking about how electric cars don't work in the in the rural communities and all that. But I think I planted a seed that hopefully they'll start to ask questions and they'll start to think about it, and they have to change themselves internally. And that's why we have to invite them into the solutions.
That's wonderful. Yeah, that's really helpful, Bill. I think it's time for us to do that, to invite folks into the solutions. And you've dropped this wonderful seed here for the way we're kind of looking at this. And it is time for us to move to our breakout rooms. And there's a couple of questions too that we're looking at, like in your breakout room, to think about, sort of what surprised you about the solutions, what had the bigger or smaller impacts, and maybe also importantly, where do you find hope in this, and how can you be a part of the guiding of the UMC, either as a person or writing a letter to your bishop or the president of the General Board of Church and Society, or coming to a United Methodist Creation Justice Movement meeting and joining in. The way we're going to do breakout rooms today is you get to choose what breakout room you're in. We're going to meet in breakout rooms for 12 to 15 minutes. And each of the breakout rooms has a listener, an experienced and wise listener. And the breakout, and basically this is a lot of information, and we just kind of wanted to make it kind of helpful to have like a small group conversation about what you heard and where you are in reflecting on that. The good conversations that are happening is why everybody pops in the very last moment. I left Kathy with a little too much time for the breakout room, so my apologies for that. We're not going to really have time to sort of debrief a bit from the breakout rooms, but we will have a workshop on this. Come back, talk about it more, think about how your Region Green Team Conference might be able to sort of bring some of this into some of the choices you make. I'm going to turn it over to Kathy, who's going to touch on a couple of things, and then Dawn is going to pray us out. If you have something you really need to share, please maybe the chat. But I again apologize for our short, but here we are. This is it. This is life. So go ahead, Kathy.
Great. So just as Bill said, the best thing that you can do with this information is to use it and talk about it. But we can use it both to share more information about what climate change is, ideas for how we address it and make solutions both in our households, in our congregations, in our cities and communities, in our states, and at all the levels that we have ability to do advocacy. We also understand that there's work to be done as we need to adapt and build resilience. And so I put in the chat the newsletter that just went out in March that was really focused on building resilience, and we will be focusing a little bit more on that in the April Café, which is the next one on April 16th. And then we're really excited to be able to bring Bill back again on April 23rd, where we're going to do a little bit of a deeper dive on that En-ROADS model, with the idea that all of our conferences and our churches, we're making decisions to how to fulfill those commitments that were made at General Conference. And if so, we need information. How do we play with those solutions so that we think in our context, in our states, in our regions, what's some of the best solutions and most ways that we can be advocating for change. So I put that on the chat and look forward to seeing you all soon. Bill, did you want to say something more?
Yes, first of all, I'm available for presentations. If you'd like to host something in the community, reach out to me. And I encourage you to play with the En-ROADS model and develop questions. My role as an ambassador is to help you understand the results that you get. But it's up to you to make the decisions and play with it. If you find something you particularly are wondering about, just copy the URL and save it away, because every one of your choices is encoded in the URL, and you can bring up exactly the same image and talk about it at a later time.
One of the reasons that Bill was an enthusiastic yes when we sort of said, Bill, would you be interested in, is because he does this. He wants to talk about it. and he wants you to talk about it. And he brings a wealth of experience, and he's an Earthkeeper and a United Methodist, which will bring him cred in your United Methodist group, right? We want to hear from each other. We're neighborly, but we're also like groupie. That's who we are as United Methodists. And so Bill would really, really love to have you email him and say that you have a group that he could talk to. All right, so we move now into our closing prayer as we do what United Methodists do together and pray. Go ahead, Dawn.
Thank you. Okay, let us pray. Gracious God, we humbly acknowledge the delicate balance of your creation and the urgent need to care for our planet. As we face the challenges of climate change, we ask for your guidance and wisdom to act with courage and compassion. Inspire us to reduce our carbon footprint, protect vulnerable communities, and work toward a sustainable future for all. May we walk lightly on the earth, respecting the beauty and fragility of your creation. Grant us the strength to make a difference, to heal the wounds of our planet, and to build a world where all can thrive. Amen.
Amen. Amen.